Assalamualaikum and hello everyone. Welcome to the video for 4.3 isomerism. In this video, we're going to learn to define isomerism, constitutional isomer, and stereoisomerism. And then we will identify and construct constitutional isomerism, which is chain, positional, and functional group. Okay, so what is isomerism? It is the phenomenon whereby different compounds have the same molecular formula but different structural formula. Okay, so that is the phenomenon, but we call the molecule itself is actually we're going to define it as isomer. Okay, isomer is the compound with the same molecular formula but different arrangement of atom. Okay, in this video, what we're going to learn is actually this one, constitutional or the structural isomer, where compound will have the same molecular formula but different structural formula. Okay, for the case of structural isomerism or the constitutional isomerism, we have chain, positional, and functional group isomer. Where chain, it differs in the structure of carbon chain. Positional, where it differs in the position of the functional group, position here. But for functional group isomer, is that for the same molecular formula, we will have two different functional group. Okay, so without further ado, let's look for the case of chain isomerism. Okay, for chain isomerism, we will have the same functional group and the same homologous series. But what is actually the difference between the molecule itself and the arrangement is actually it will differ in the carbon skeleton or the carbon chain. Chain here, the name of the chain isomerism. For the case of chain isomerism, here is actually first thing first, it's actually you have to know what is the longest carbon chain for a given molecule. Okay, so let's look for our first example is C₅H₁. Okay, so first here, the longest carbon chain present is actually, you look based upon the number of carbon present. C₅H₁, the longest one is actually 4. So we're going to write down longest carbon chain kita akan 4. So what we're going to do is actually we're going to draw 1, 2, 3, 4. Remember that for each carbon must have 4 bonds. And this is not the only structure. Remember we have H10. So we're going to fill up the rest with our hydrogen. Okay, so this is actually the first structural formula for the case of C₅H₁. Structural formula here. Okay, so for the case of chain isomerism, actually it will be easier for you if you know the name of it. So in this chapter, we're not going to learn in detail about naming. Later, we're going to learn detail during our chapter 5. So this is actually an alkane where the longest chain is actually 4. So the longest one, kalau 4, the name will be butane. Okay, so this is the expanded structure. If the skeletal structure will be like this. This is the first carbon. 1, 2, 3, 4. So here, 1, 2, 3, 4. So this is the butane. So this is the first structural formula. Next, remember here, it mentioned that the isomer will differ in carbon chain or the carbon skeleton. We're still going to talk about the longest carbon chain. So tadi, the longest carbon chain is 4. Okay, next we're going to look at is actually minuskan 1 this value. So we're going to minus 1. So what we get is actually longest carbon chain is 3. So we're going to draw carbon chain panjang dia 3. But then for this case we have 4 carbon. So where should we put the carbon? Should we put it here? Should we put it here? Kat mana? If you put it here, then the longest carbon chain will be 4, which is the same as this one. If you put it here, pun sama gak? 1, 2, 3, 4. So the same goes here. So how should we do it? So if you put it in the middle here, okay. Regardless of where you counting it, you will get 3. 1, 2, 3. Or here 1, 2, 3. Or here 1, 2, 3. Okay, here is the longest carbon chain is 3. So what should we do next? Remember, for each carbon must have 4 bonds and that must be bonded to our hydrogen. Okay, so this is actually the structure. Okay, how about the naming first? We're going to look at the naming. Okay, the longest carbon chain is actually 3. So for 3, the name will be propane. Okay, but then if only propane, here we have another one more carbon. So how are we going to name it? Okay, so here is actually nanti kita akan belajar lagi chapter 5, no worries. Okay, remember for alkane, so CH4 is methane. So here is actually not CH4, so the name won't be methane propane. So it is actually, this is an alkyl group. The alkyl is actually, it is based from the alkane, but then we're gonna minus 1 hydrogen. So if alkane is CH4, we call it methane. For the alkyl group or alkyl group will be CH3 because the hydrogen minus 1. The name will be methyl ataupun methyl. Okay, but then we have to write down here CH3 ni, methyl ni pada carbon number berapa. When we count from here, here is actually carbon number 1, carbon number 2, carbon number 3. So the name is actually, on carbon number 2, we have our CH3 is methyl or methyl gitu. So the name would be, okay, so that is actually the name of the structure. Okay, it's not only about we're gonna name it as in ni. Mesti kita akan tengok methyl ataupun ethyl lah. Okay, next is actually you have to know on carbon number berapa yang ada, we have our CH3, our alkyl group here. So what about the skeletal structure? The skeletal will be 1 here, 1 here. So 1, 2, 3. 1, 2, 3 carbon, and on carbon number 2 we have our CH3, which kalau carbon, we're just going to draw a line lah. Regardless, you want to point up there ataupun down here, mana-mana pun boleh. But I'm going to show it here lah. Okay. So this is the longest chain 3. So when you count it back again, from here actually, when you count your carbon is 4, and then your hydrogen is 7, here is 10. So this is actually C₅H₁, here pun C₅H₁. As you can see, it has the same molecular formula but different arrangement. Okay, so this is the examples. Okay, next, kalau carbon longest carbon chain, bolehkah kita buat minus 1 lagi? If there is only 2 carbon, okay, the maximum yang ni C₅H₁ kan? So we're going to put carbon here, or going to put carbon here. Actually, when you count it, you get 1, 2, 3, 4. So there is no longest carbon chain. Is 2. There is no of it lah. There is none of when the longest carbon chain is 2 for C₅H₁. So that is actually for the first example. Now let's look for the second example where it is C₅H₂. Again, what should we do is actually we're going to take our longest carbon chain, which must depends on our the molecular formula itself. So for the molecular formula is 5, so it means that the longest chain must be 5. So what I'm going to do is actually, again, 1, 2, 3, 4, 5. Remember, carbon must have 4 bonds and then must be bonded to hydrogen. Okay, so here is actually the longest carbon chain is 5, which is our, kalau 5 is actually pentane. And then if for the skeletal structure, it will be 1 here, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the skeletal structure. Okay, next is when the longest carbon chain is 5 minus 1, so we get 4. So the longest carbon chain is 4. So what should we do? Okay, so again, we're going to draw 4 carbon. So 4 carbon, 1, 2, 3, 4. So we can't put at the end here because later it will be 5. And so what we're going to do is actually put in the middle. So in the middle here, I'm going to write now sini carbon. Okay, so going to finish up the rest of the molecule. Make sure it's 4 bond and hydrogen. So how about the naming? Okay, longest carbon chain is 4, so 4 must be butane. Okay, and then on carbon number what? Okay, we have our methyl juga, the same case as our longest carbon chain here. Remember, for the case of CH3, we have to show the numbering lah. Okay, so what is the number? We want it to be the smallest number. So if you want to do it here, 1, 2, 3, 4. Here nanti dia akan jadi 3 methyl. We don't want that because actually we want it to be the smallest one. So what I'm going to do is actually number from here. 1, 2, 3, 4. Okay, so the name will be 2-methyl butane. Sama juga from this one up here. So it will be 2-methyl butane. Okay, so which way would be the number? The numbering should start here. Number 1 here, number 2 here. So this is 2-methyl butane. So for the longest carbon chain is 4. Is there any possibility? Another possibility. Okay. It's just okay. If you put it 4 here, okay kan? And then right now we're gonna put the carbon chain dekat sini pula, at the side here pula kan? But actually when you put your carbon here, nanti nama dia pun jadi sama juga. Here jadi 1,2, 2-methyl butane. So it's the same thing. So this is actually the only possibility for longest carbon chain is 4. Okay, what is the skeletal structure? 1, 2, 3, 4. And carbon number 2 here, I'm going to put methyl. So up to you, downward or upward. So I'm going to draw it this way. Next longest carbon chain is actually when the carbon chain minus 1 lagi, you will get your longest carbon chain is actually equal to 3. Okay, so when it is equal to 3, so the longest one must be 1, 2, 3. Okay, remember this is C5, right? So where should we put it? Remember we can't put at the end there because later nanti akan dapat sama juga. So I'm just going to put in the middle here. But then we only have 4 carbon. This is C5. So where we're going to put our carbon? Sebenarnya kita kena letak sini carbon. Okay, so this is actually the structure when the longest carbon chain is equal to 3. So remember this is C₅H₁₂, right? So what should we do next is actually make sure each of the carbon must have 4 bonds and bonded to hydrogen. Okay, so this is actually the structure. Okay, so how about the naming? Okay, the naming here, the longest one is 3. So the name will be propane. Okay, but then on this case, when we count it, here, carbon 1, 2, 3. So on carbon number 2 here, we have 2 carbon yang CH3, right? So we have methyl. But this case, we have 1, 2. So the name would be dimethyl. Dimethyl. Okay. Why di? Di because we have 2. Kalau 3 we have trimethyl lah. Tapi this case carbon ni ada CH3 ni there's 2 only kan. So dia jadi dimethyl. And at what position? Pada carbon number 2. Tapi sebab dia ada di kan. So we have to show 2 dimethyl. Carbon number 2, dimethyl. Okay, so how do we get here? Okay, kalau kamu pening ni, it's okay. Later kita akan tengok lagi in detail during chapter 5. Here is actually only a brief introduction lah to the naming itself. Okay, so when you look based upon here, then you can see that each of the carbon, the arrangement is very different. But it has the same structural, the same molecular formula. Here C₅H₁, here pun C5, H kat sini pun H12, sorry. Here pun carbon dia 1, 2, 3, 4, 5. Here 3, 6, 9, 12. All of it, here, all of it has the same molecular formula, but different structural formula, different arrangement. The same goes for here. Okay, so we're going to continue with the next one.
Next, kita tengok untuk C₃H₁. Again, first step kita buat the longest carbon chain, which is based on the molecular formula, dah adalah 6 lah. Okay, tapi sebenarnya I don't want to do the expanded lah, nak buat skeletal. So it is easier. Okay, so 1, 2, 3, 4, 5, 6. So here is my 6 carbon. Okay, so here is, kalau senang nak buat naming dia, means buat nama dia adalah, it is actually hexane. Okay. Next adalah longest carbon chain is equal to 5. So kalau dia 5, okay, make sure it's 5 carbon. Okay, lepas tu where's another 1 carbon I'm going to put. Jangan at the end nanti akan dapat longest carbon chain, means akan dapat 6. So I'm going to put in the middle here. Okay, so bila I put in the middle here, okay, senang buat naming. Dia adalah pentane sebab the longest chain is 5. Tapi pada carbon number 2, there's actually one of the chain branch dia ataupun substituent, which is the name adalah methyl. CH3 name dia adalah methyl. Okay, so dia adalah 2-methyl pentane. Okay, actually for the same longest chain, which is 5, Miss boleh buat lagi satu isomer, sebab when I draw it down and I name it, it's actually, it has the different name. Sebab ini adalah carbon number 3 pula. So here the name will be 3-methyl pentane. So boleh ke kalau Miss nak buat 4-methyl pentane? Okay, tapi sebenarnya for naming tu kita sebenarnya sebenarnya kita akan buat the branch tu the smallest number. Sebenarnya kalau kita draw macam ni, this actually dia adalah 2-methyl pentane. So sama sajalah. So this is actually the 2 possible isomer when the longest chain is 5. So now adalah the longest carbon chain Miss nak buat adalah 4. So the longest carbon chain equal to 4. So again kita buat 1, 2, 3, 4. Make sure kita tak akan buat the longest chain, tak akan tambah dia punya branch di hujung sekali, sebab nanti akan jadi 5. The same goes on both side lah. Okay, so we're going to put in the middle here. Tapi carbon kita baru ada 5. We want our carbon to be 6. So we're going to put another one. So again tak nak kat tepi sebab nanti akan dapat 5. So if I put it at this carbon, okay, so kita tengok we have C₃H₁₀. How to name it? Longest carbon chain 4. Lepas tu pada carbon number 2 dengan 3 adanya kita punya methyl. Tapi kita kata dia ada dimethyl because there's actually 2 of our CH3. Ataupun sebenarnya kita boleh buat kita punya branch tu ataupun substituent kita on the same carbon, which is carbon number 2. So yang ini copy paste sahaja naming dia. Okay, sebab pada carbon number 2 2 dimethyl butane, so at the same carbon. Okay, so again jangan, make sure the longest carbon chain dia, lepas tu kita buat branch dia lah. Okay, tapi tadi kita mostly ada guna longest carbon chain is equal to 3. Okay, so kita boleh cuba. Okay, so contohnya kalau alamak sebenarnya senang yang ni buat expanded. So ataupun Miss buat carbon je lah dulu. So carbon, so macam mana kalau carbon equal to 3, tapi here carbon is equal to 6. So yang ini longest carbon chain kita paling dapat sebenarnya 4. So there's no of my longest carbon chain equal to 3.
Okay, we have a look at for the chain isomer. Next is actually we're going to look at for the case of positional isomer, where the positional isomer we have the same carbon skeleton and same homologous series. So for the case of positional isomer, there's no need for you to do the longest carbon chain. There's no need of it. But then, what is actually for the case of positional isomer, it will differ in the position of the functional group itself. So let's look here.
So let's look for the first case. We have C₃H₁₀Cl. So here I have my carbon, and then remember each carbon ada 4 bond. Okay, and then ingat functional group is my halogen. Okay, so my chlorine I want to put it first pada first carbon. So okay, so the rest of my carbon I'm going to finish up with my hydrogen. So here is the first isomer for C₃H₁Cl. Next one, masih lagi 3 carbons but same carbon skeleton, which is 3. Okay, kita akan buat, make sure each carbon ada 4 bond. Tapi sekarang ni position of chlorine is at different carbon. Okay, so tak nak kat carbon number 1, so I want to put it sebab Miss nak letak pada different carbon. So carbon number 2 lah pula. So then the rest of it I'm going to put hydrogen. So this is the example of our positional isomer. Okay, position of chlorine dia berbeza, tapi carbon and hydrogen the same number. Sekarang ni kita tengok for the second one, C₅H₁₀OH, tapi Miss nak buat skeleton lah. So the longest one, carbon mestilah 5. Okay, so first Miss nak letak OH di mana? Miss nak letak OH pada carbon number 1. Okay, tak kisahlah mana satu kamu nak label carbon number 1. Okay, so here is my first isomer. Second one adalah Miss nak letak OH at the second carbon. Okay, tapi Miss boleh juga letak pada carbon number 3. So here I have different positional isomer. Okay, tapi boleh tak Miss nak buat pada number 4? Tapi kalau Miss buat number 4, nanti dekat sini dia jadi same lah dengan second carbon OH pada second carbon. Okay, so tapi yang ini macam pening sikit kan? Tapi tak apa, nanti pada chapter hydroxyl nanti kita akan nampak lagi lah pada naming. Sekarang ni the last but not least is the functional group isomer, where it have the same molecular formula. Tapi it actually differ functional group and homologous series. So sekarang kita akan tengok pada CnH2n plus 2O. Okay, so first misalnya nak buat alcohol. So there are 2 carbon here, and then jangan don't forget each carbon have 4 bond. Okay, tapi alcohol functional group bond pada OH. Okay, so the rest I'm going to write down hydrogen, hydrogen, hydrogen. So right now I'm going to write down for ether. So kalau ether, okay, again they bonded to oxygen. So oxygen is in the middle of 2 of our carbon. And then carbon kena bonded to 4 bond. Oxygen memang cukup saja 2 bond. Okay, carbon kenalah ada 4 bond. And then we're going to finish up. Okay, and then kita tengok. So that's the isomer for ether. So kita tengok number of carbon dengan hydrogen, oxygen dia pun sama sahaja. So sekarang ni kita tengok for the case of CnH2NO, aldehyde dengan ketone, where it has the same functional group as C double bond O. So sekarang ni first I'm going to draw for the case of my aldehyde. Okay, so again carbon nak 4 bond. Okay, tapi remember aldehyde functional group dia adalah C double bond O hydrogen. Okay, and then kat sini misalnya ada double bond O dengan H, tapi sekarang carbon dah lebih daripada 4 bond. So I'm going to remove one of the bond. Okay, and then carbon dah cukup 4 bond. The rest of it I'm going to write down dengan hydrogen. So that's for aldehyde. Kalau ketone pula, okay, it's different. Okay, kalau for the case of ketone, okay, dia punya bodyguard dia dua-dua adalah carbon. Okay, bodyguard lah, it must be surrounded by carbon lah. Kalau aldehyde, bodyguard dia satu hydrogen, satu carbon. So here misalnya letak double bond O in the middle, so bodyguard dia dua-dua carbon. Okay, so I'm going to finish up the structure. So here is my aldehyde dengan ketone. Kita tengok nama carbon, hydrogen dengan oxygen dia sama sahaja. The third one adalah carboxylic acid and ester. So carboxylic acid, dia punya hujung must be C double bond O OH. It's actually at the end there. So kat sini Miss nak betulkan. Okay, so here C double bond O OH, carbon must have 4 bond only. So the rest is actually hydrogen. Okay, so for the ester, dia dah C double bond O, tapi sekarang ni the O tu, single bond tu bonded to another carbon. Okay, so contohnya kalau I'm gonna write down 3 of my carbon here. So kalau ni jadi O, sini C, tak boleh lah sebab dah we only have 3 carbon. So the double bond O must be in the middle. Okay, and then must bonded to O. C tu must bonded to O, and O is bonded to another carbon. Okay, and then cukupkan each of the carbon must have 4 bond. Okay, and then we're going to finish up with our hydrogen. So this is actually our isomer for CnH2NO2, carboxylic acid and ester. Last but not least is for the case alkene and cycloalkane. Okay, so alkene, so maknanya it has 1 double bond. Okay, lepas tu kita nak cukupkan each of the carbon must have 4 bond. Okay, and then we're going to finish up with our hydrogen. Okay, so that's for alkene. So how about cycloalkane? Okay, cycloalkane ni cyclic structure lah. So dia boleh jadi macam-macam bentuk lah. Okay, so dia adalah C₅H₁, so maka dia adalah cyclobutene. So carbon kita buat in cyclic structure, and then kita cukupkan carbon tu dengan semua 4 bond. So we have C₅H₁. So that's actually for the functional group isomer for alkene and cycloalkane. So let's look at the example on page 10, example B. So here is actually our structure here with our alkene. Okay, so first kalau alkene, apa kita boleh buat adalah positional isomer. We're going to change the position of functional group. Okay, lepas tu, okay, but then sebenarnya ada banyak lagi isomer we can do. So next step apa yang kamu kena buat adalah actually hint dia adalah draw ataupun write down the molecular formula. So I have C₅H₁. Okay, so C₅H₁, so maknanya next Miss nak buat the longest carbon chain Miss adalah 3. So here is actually my chain isomer. Okay, and then for the case of alkene, there's actually functional group isomer, where alkene mestilah dengan cycloalkane. So kalau C₅H₁, dia adalah cyclobutane. Okay, but actually we can actually draw another one is actually cyclopropane dengan satu substituent ataupun satu branch. Because when we count it back here, kita tengok, okay, sini we have C₅H₁. Okay, the same goes for kalau cyclobutane memang C₅H₁. Yang ni kita tengok balik. Kalau kamu tak pasti, you can check your answer with calculating the number of carbon and hydrogen. So dia adalah C₅H₁. Okay, tapi macam mana kalau contohnya dia bagi memang molecular formula sahaja. Kalau macam ni sebenarnya kena hint senang start dengan chain isomer. We're going to start with the longest carbon chain. Then remember, that's actually bromine. Okay, so sekarang ni Miss nak ubah position of my functional group saja, but still the same case for the position isomer. Longest carbon chain. Chain isomer. So next adalah longest carbon chain is actually equal to 3. Okay. Yang ni memang ada sure lah ada 3 longest carbon chain, and another one adalah pada branch dia. Okay, tapi jangan lupa pada bromine. So boleh buat pada carbon number 1 kita, ataupun boleh buat pada our carbon number 2. So it means that this is actually different isomer lah, sebab bromine ni pada position yang lain. Walaupun methyl pada position sama, bromine position berbeza. So here is actually the possible isomer. Okay, so here is actually the hint. Kalau contohnya dia bagi kamu kena write down molecular formula. Ada certain dah bagi dah, ada certain tidak. So you have to write down lah, senang kira berapa carbon, berapa hydrogen. Next actually adalah kamu draw dulu chain isomer. Once kamu dah change isomer, barulah boleh buat positional isomer by changing the position of our functional group. Okay, tapi kalau yang next, kalau ada certain yang memang boleh, kita boleh buat functional group isomer. Yang tu kamu kena tengok pasangan dia lah.